Greetings, we are Team Unpredicting and we would like to present our project on data analytics. The team comprises of Akash Rao, Ishan Agarwal and myself, Raghav Goyal. Students' academic performance depends not only on the amount of studying but various other factors that may not be conventional. The problem that we have taken upon us is one of predictive analysis. We have tried to identify the various factors that influence the grades of high school students and understand their relationship to predict the final grades using students' general behavioral patterns. To do this, we have used dataset from Kaggle, which was originally created by Paulo Cortes and Alice Silva of University of Minho, Portugal. The dataset consists of information regarding high school students, which was collected through questionnaires and report cards. The dataset not only comprises of general student information such as age, gender, and study time, but also some unique features such as family education background, alcohol consumption, travel time, etc. The dataset is fairly clean and well received by the community. It contains 395 rows and 33 columns. The resultant attribute of the dataset are the student grades in 3 exams. So why is it important? Education has great potential to change the world. When a society is educated, there is a great allocative and productive efficiency with rapid rates of development. Being college students ourselves, the problem is one that we have encountered ourselves. There is one predefined notion that working hard alone and putting in study time will provide good results. However, that is not the case, and we have strived towards answering this question. Schools and institutions can understand the various factors that affect student performance and guide the students for improvement. Predictive task has wide-ranging applications and can be integrated with various other platforms such as educational portals, online courses website, auto report card evaluation, etc. So what is our approach? We have approached this problem as a predictive analysis one. The domain lies in supervised learning. This required us to first pre-process the data to suit our aim. Since the data was fairly clean, it did not require us much work. The dataset consisted for both numerical as well as categorical data and thus needed feature encoding. The dataset also consisted for large number of columns due to which there was scope of collinearity among the independent features, and we have checked for it using correlation coefficients. Our aim was to predict the final grades without any previous grades data, and so we have added the final grades table combining the score of all the 3 grades and dropped these 3 grades columns. The predictive analysis required us to do regression on the data and open possibilities for various learning models. We have focused our attention on 8 main models, namely random forest, support vector machines, k-nearest neighbors, neural networks, and linear lasso, ridge, and elastic net regression. The general overview of model building was first building the model architecture, fitting the model to the data, and using the model for prediction. With some deviation from this approach, such as scaling the data, we were able to implement all these learning models. The models were then compared using root mean square error, the mean absolute error, the R-square score, as well as the cross-validation report. With a bit of tuning, finally we came to the conclusion that random forest exceeded in its predictive capabilities, and so we improved upon the random forest model. The random forest model was optimized and tuned. The first approach was to tune the various hyperparameters involving in the model. After getting our hands dirty in manual tuning, we opted for rigorous search for various optimum parameters using randomized search and grid search. The resultant model, however, performed worse than the original one, and so we sought to use other techniques. We finally decided to do feature selection using random forest model coefficients for the features and remove the features which did not have much impact. We came to use 0.008 as a threshold and finally achieved some better performance. The importance score, which was the feature coefficients, clearly displayed the factors that are most impacting the student's grade. It shows that increasing the study time alone and last minute cramming does not have some great improvement on grades, but instead having long-term plan involving reduced absent days and maintaining good health proves to be far more beneficial than expected. Having support from family in academics is also beneficial. All this goes along with the results in other researches as well. We managed to dig up some other findings as well and are eager to apply in our lives. The lower free time means the lower the grades, so it's important to utilize the free time as well. The study time does not affect the grades alone, so it's the quality of study over the quantity. And romantic relationships do not help the academics for sure. Even though the best, the final models still have large amount of error and deviation from true values due to the use of unique and uncustomary features used and not relying on past academic performance. A lot of learning and work had to be done, which was efficiently distributed among the three of us, which made the whole project a whole lot of fun. Due to COVID 19, we were all separated and tried our best to effectively communicate and keep each other accountable. Akash helped with exploratory data analysis and data pre processing. I was majorly involved in trying out various models and tracking their metrics and comparing the results. Ishan helped with selecting a model based on metrics and improving it further using different techniques. The final report is the culmination of collective effort by all of us. Thank you.